Hello. So in this video specifically is about geometric sequences. It's our third assignment in Unit 9, and it's about geometric sequences. So geometric sequence is a little bit similar to an arithmetic sequence, but it's different in that it does not have a common difference. In a geometric sequence, what it has is what is called a common ratio. A common ratio, we're going to call it R, is what you multiply the previous term by to get the following term. For example, in this particular sequence here, I multiply 5 times 2 to get 10. 10 times 2 gives me 20. 20 times 2 gives me 40. 40 times 2 gives me 80. So I'm repeating by multiplying by the number 2. And because I'm repeating my multiplication, that is called a geometric sequence. So the two common formulas that we're going to use here, first is a recursive formula and then an explicit formula. And a general form for a recursive formula is a sub n. Now remember, in a recursive formula we always look at the previous term at a term by looking at the previous term and trying to figure out what do we do to the previous term to get the term that we're looking for. And in this particular case, we take the previous term, which is a sub n minus 1, and multiplying it times the common ratio. This example would be times 2 because the ratio is 2. In an explicit formula, it's a little bit different because we're not necessarily looking at the previous term, but the actual term number. Like 5 is the first term, 10 is the second term, the third term is 20, and 4, and the fifth term is 80. So in general, we're going to look something like this. We're going to start with the first term, but what we do is we multiply by the common ratio n minus 1 number of times. Let me explain this using this simple example here. In order to get our second term, which is 10, we started with our first term, which is a sub 1, and we multiplied it times 2 once. In order to get our third term, we could start with 5 and multiply it times 2 twice. In order to get our fourth term, we start with our first term, which is 5, and we multiply it times our ratio, which is 2, not 4 times, but n minus 1 number of times. So this is a general formula that we can use to write an explicit formula for every geometric sequence. Let's take a look at a specific example. Here we have the salary of a secretary. Let's say that she's been offered a position, and her first year she's going to make, or he is going to make $26,000, but she's going to get a 4% raise every year. A 4% raise means that we're going to multiply by 1.04 to get to the next salary. So in her second year, the salary is $27,040. And the next year, we multiply by 1.04 again, and it's $28,121.60. And every next year, she's been promised a 4% raise. So what we want to do is figure out what is her salary going to be in 18 years. Let's say she's been on the job for 18 years. We should be able to figure out what her salary is on just her 18th year. Well, before we get to that question, let's start by writing a recursive formula for this particular example. Recursive formula is a sub n equals the previous term, which in this case, a sub n minus 1, and we're going to multiply it times the common ratio, which in this case is 1.04. This is a recursive formula that describes this particular geometric sequence. The explicit formula for this particular geometric sequence is going to look like this. A sub n is going to equal the first term, which is $26,000. And what we're going to do is multiply it times the common ratio, which is 1.04. Not n number of times, but n minus 1. Sorry, this should be the exponent, but n minus 1 number of times. So, for example, to get to the third salary, I would start with $26,000 and I'd multiply it times 1.04 twice. So instead of saying 1.04 times 1.04, it would be 1.04 squared to get to the third salary. This example, this equation is what I could use then to figure out what she's going to get paid on the 18th year. The 18th year, or the 18th term, is going to be $26,000 times 1.04 to the 18 minus 1, or 17th power. And if we use our calculators to figure out what that is equal to, I should have done this before we started, but we will take 26,000, we're going to multiply it times 1.04, and we're going to raise that, no, I messed up. We're going to raise that to the 17th power, and I don't have, I'm not going to be able to figure out what the actual answer is for that one. Oh, actually I do have it written down. It is $50,645.41, and that's how much she would get paid on the 18th year that she is working at this particular, with this particular company. And that is an example of a geometric sequence. Let's take a look at a couple more, and what I would like for you to do as we go through and do these examples, what I'd like for you to do is try them on your own before I go through them on the video. So here we have a simple geometric sequence. What I would like for us to figure out is what is the recursive formula and what is the explicit formula. You can pause the video and try to figure this out on your own. And then we'll get back and try to figure it out together. The recursive formula is going to be this. We're going to start a sub n is going to equal the previous term, which is a sub n minus 1, and we're going to multiply it times 2 because the common ratio is 2. I'm multiplying by 2 each time to get my next term. So there's my recursive formula. My explicit formula is going to be a sub n is equal to the first term, which is 3. I'm going to multiply 3 times 2 because that's my common ratio, n minus 1 number of times. So if I want to figure out, let's say, what the 32nd term in this sequence is, I will have a sub 32 is equal to 3 times 2 to the 32 minus 1 power. That's the 31st power. And if we do that on our calculator, I believe we get 6,442,450,944. And that would be the 32nd term of this sequence. Let's go ahead and look at the third example that we have here. This is a little bit different because the common ratio is actually less than 1. We start with 80, but then we end up with 60 and then 45 and 33.75. How do we figure out what the common ratio is? Well, we can always take, just like we did here, 6 divided by 3 is 2, 12 divided by 6 is 2, 24 divided by 12 is 2. We can find the common ratio here by taking 60 divided by 80, or 45 divided by 60. That gives us a common ratio of 0.75. So 80 times 0.75 is 60. 60 times 0.75 is 45. 45 times 0.75, or 3/4 of 45, is 33.75. So our recursive formula. Our recursive formula is going to be a sub n equals the previous term, which is a sub n minus 1, times the common ratio, which in this case is 0.75. The explicit formula is going to be a sub n equals the first term, which is 80, times our common ratio, which is 0.75, to the n minus 1 number of times. So suppose that we are looking for the 50th term in our sequence. We are going to find a sub 50 by taking 80 times 0.75 to the 49th power. and that ends up being 0.0000604. This is very similar to exponential decay, as this is very similar to exponential growth. So let's take a look at what a geometric mean is. If I asked you to find the average of 8 and 32, most people would say the average, which is commonly the common name for the arithmetic mean, the average would be 20. Simply because 20 is halfway between 8 and 32. It's 12 more than 8, 32, and 12 less than 32. But this is the arithmetic mean. What I want is the geometric mean. You can also make a good argument that the average, or the middle of those two numbers, is 16. And here's why 16 would be a good answer. 16 is twice as much as 8, but it's half of 32. So we can make an argument that 16 is right in the middle of 8 and 32. This is a geometric mean. We find geometric means by taking a common ratio, like for example, 8 over 16 is equal to 16 over 32. Both of those are equal to a half. Suppose we didn't know that the geometric mean was 16. Let's say we call it n. We could say 8 over n is equal to n over 32. And we could find n, if we didn't know that it was 16, we could find n by cross multiplying. N times n is n squared. 8 times 32 is 256, must be 256. And so then when I take the square root of both sides, I'll have that n is equal to 16. In short, here's what we did. In order to find the geometric mean of 8 and 32, I multiplied them together. Let's say the two numbers are a and b. I multiplied a times b together and got 256, and then I took the square root. So to find our geometric mean, we're going to take a times b and take the square root of the two. Remember that our arithmetic mean was to take a plus b and then divide them by 2. So this is very similar to finding the arithmetic mean. We're looking for a number that's in the middle, but the geometric mean means that you multiply them together and take the square root. So if I want to find the geometric mean of 28 and 5,103, I'm going to take 28 times 5,103. And then I'm going to take the square root of that, which is 378. And it should be that if I figured out 28 over 378, that's equal to 378 over 5,103. And that's how we find the geometric mean. So our homework assignment now is assignment number 3. We will hopefully do well with that, and I will see you tomorrow.